Good afternoon, everyone. I'm Shohei Riya from Tokyo University of Agriculture and Technology. Today, I talk about carbon and nitrogen flow in the pig farming system and how to improve them by using dry anaerobic digestion and rice cultivation. Carbon and nitrogen flow in the pig farming system is not so sustainable. So this figure shows us material flow in the swine manure, pig farming. So first, carbon and nitrogen was put into the pig farm as a feed, and it is converted. The carbon and nitrogen in the feed is converted to living pig and swine manure. Swine manure and solid manure is treated by the composting, and liquid manure is composted by the wastewater treatment system. And during these operations, atmospheric pollutants such as methane, nitrous oxide, or ammonia is emitted. And composting can produce fertilizer, but a large amount of compost is produced. So not all of the compost can not be used. So this is oversupply. And for wastewater management, some farmers cannot manage this facility well. So effluent nitrogen concentration is sometimes higher than environmental standard. So to overcome these problems, we focusing on dry anaerobic digestion. So dry anaerobic digestion is a process in which organic carbon is converted to CO2 and methane in the absence of oxygen by microbes. Then these gases are called biogas. It is used for renewable energy. And in addition, during anaerobic digestion, organic nitrogen such as proteins are mineralized into ammonia. It is a nutrient for plant. So anaerobic digestion can produce renewable energy and fertilizer. Generally, anaerobic digestion is conducted in the liquid form, So it produces a large amount of wastewater rich in the ammonium nitrogen, so which should be treated. On the other hand, if the digestion is conducted at a low water content, about 80%, it's called dry anaerobic digestion. In the dry anaerobic digestion, the content of the reactor is like a solid state. Therefore, no wastewater is produced. So this dry anaerobic digestion is more useful to treat manure waste. So by using this dry anaerobic digestion, we propose a new pig farming management system using dry digestion and rice cultivation. So in this system, swine manure is treated with rice straw to produce biogas without wastewater production. And nitrogen in the swine manure is remained in the digested residue. So this is fertilized in the rice field to produce grain for pig feed and rice straw for the anaerobic digestion. So by using this system, we think carbon and nitrogen flow in the pig farming may be improved. But to apply this system, we have to consider these three problems. The first one is how much rice straw is needed for the swine manure digestion. The second one is carbon and nitrogen dynamics in the rice field amended with digested residue. Because a rice field is known as a source of strong greenhouse gas, methane. So therefore, we have to check digested residue application increase methane emissions or not. And if increased, we have to study how to reduce them. And the third problem is how this system can improve carbon and nitrogen flow in the entire system. So today's talk, I talk about these three topics. And first, I talk about how much straw is needed for the digestion. And we focusing on the carbon and index of carbon and nitrogen ratio. Carbon and nitrogen ratio is a ratio of the carbon and nitrogen in the substrate. So this is a very important parameter in the anaerobic digestion because nitrogen is required for the growth of the microbes in the anaerobic digestion. While if the nitrogen concentration is very high, microbes are inhibited and the methane production is decreased. So and generally manure contains less carbon and higher concentration of nitrogen. So we have to control nitrogen concentration in the pig manure. On the other hand, plant residue such as rice straw or corn stover contains more carbon and less nitrogen. So adding plant residue into manure can increase carbon and nitrogen ratio in the pig manure and may improve methane production. So we have to conduct research, investigate best carbon and nitrogen ratio of the manure and rice straw. So we conducted a laboratory incubation study, and we compared three carbon and nitrogen ratio. So CN ratio 8 is digestion of swine manure only, and CN ratio 20 and 30, different amount of straw was added, and they are incubated in the digester, in the semi-batch digester. And this is a result of the anaerobic digestion. When digesting only manure, methane yield was very low, about 100 cubic meter per ton. And ammonium concentration was higher than 3,000, which is an inhibitory level. When rice straw was added and the CN ratio was increased, ammonium concentration was decreased to less than 3,000, and methane yield was significantly increased. Therefore, CN ratio control adding rice straw is effective to improve methane emission from pig manure. And CN 20 and 30 is optimum for the pig manure digestion. So after anaerobic digestion, we got digested residue rich in the nutrients. So we use this as a fertilizer in the rice field, and we investigated carbon and nitrogen dynamics. So this figure shows carbon and nitrogen cycling in the rice field. Generally, rice is cultivated in the flooded condition. So carbon and nitrogen in the soil is anaerobically decomposed, and carbon is and methane and ammonia is produced. So methane is emitted to the atmosphere and affect global warming, and ammonia is taken up by the rice plant. On the other hand, when soil is dried, organic matter is oxidized into carbon dioxide without CH4 production. So drying soil is a good option to reduce methane emission. So we investigated the effect of digestion residue application on methane emission, and investigate effect of soil drying to reduce methane emission, and quantify other carbon and nitrogen dynamics. And we conducted a field experiment. We prepared several small experimental plot and cultivate rice. And we applied these three treatments. First one is conventional farming. This is applying chemical fertilizer and flood water management. And second one is residue plus flood. This is applying residue as a fertilizer and flood water management. And third one is residue plus intermittent irrigation. In this management, residue was applied as a fertilizer, and intermittent irrigation, in which water was applied 2 or 3 days interval to create oxidative condition in the soil to reduce methane. Methane emissions from the rice paddy was measured using chamber method. So in this method, put this chamber to the soil and take a gas inside the chamber at a regular interval and and calculate methane emission rate based on the increase in the methane concentration in the inside of the chamber. And this figure shows a total methane emission during cultivation season. From the lowest methane emission was observed in the conventional farming, and when residue was added, methane emission was increased 5 times. So digestion residue increased methane emission from the rice field. And when intermittent irrigation was applied, the methane emission was reduced to 40%. So intermittent irrigation is effective in reduced methane emission. And this graph shows other carbon and nitrogen dynamics in the rice field, shown in the fraction of applied residue carbon and nitrogen. Methane and leaching. Leaching means go to the underground. These fractions are very small, about 10 or 20%, and large fraction of the carbon and nitrogen were found in the soil, accumulated in the soil. This means these carbon and nitrogens were hardly decomposed during rice cultivation. And this is, we think this is beneficial in the system because carbon in the digestate is originally coming from photosynthesized CO2. So accumulation in the carbon is means the CO2 storage in the soil. And also nitrogen is also coming from the manure. And this is also nutrients. So this is also beneficial for the plant growth in the next season. So we quantified green carbon nitrogen dynamics in the anaerobic digestion and the rice field. So finally, we evaluated carbon and nitrogen flow in the entire system. So in this calculation, in the analysis, we compared conventional system and dry digestion system. So conventional system, we calculated gas output and input in these systems. And in the conventional system, feed was added and gaseous compounds were emitted during each process. And also in the composting process, sawdust was added as a water content adjustment, and compost was produced. And for the wastewater treatment system, the water was added to the dilution of urine nitrogen, and effluent is also discharged. For dry digestion system, in the rice field, during rice growth, CO2 was photosynthesized. So this is accounted as input, and other gases and water component was emitted in the other processes. And these carbon and nitrogen flow was calculated per one living pig production. And these calculations were conducted using literature value and experimental result. And dry anaerobic digestion was conducted at CN ratio 20, and rice cultivation was conducted by using intermittent irrigation. And after that, we compared emission of carbon and nitrogen pollutants from the entire system, and also calculate conversion efficiency to the products. This is a carbon and nitrogen balance in the conventional system. So feed, compared with feed production, living pig carbon and nitrogen to a small fraction. Therefore, conversion efficiency is not so good. And remaining carbon and nitrogens were allocated to the gaseous form and manure carbon and nitrogen. And for dry digestion system, CO2 is inputted by the photosynthesis. The amount of the CO2 was very high. It is higher than the feeding carbon, and some produced grain and straw and grains were added to the dry anaerobic digestion to produce biogas. And residue is returned to the rice field as a fertilizer, and some carbon and nitrogens were accumulated in the soil. And this is a summary of carbon and nitrogen emission in the gas and water from each system. For methane, dry digestion emits more methane than conventional system. This methane, most of this methane is coming from rice field. Therefore, methane emission from the rice field in the dry digestion system is very important and should be reduced. And for nitrogen emission, all components, the dry digestion systems were less than conventional system. So therefore, dry digestion system emits less nitrogen pollution to the environment. And finally, we calculated total carbon and nitrogen loss and the carbon conversion to the product. So when we consider 1 kilogram nitrogen as input, half of the carbon and nitrogens were converted to the products and lost into the environment. While in the dry digestion system, the product carbon and nitrogens were higher than conventional system. Therefore, dry digestion system can efficiently produce carbon and nitrogen products. And this is because of the accumulation of the carbon and nitrogen in the soil, and also photosynthesis by the rice plant. And also, CO2 is removed from the soil. Loss of water, loss of the carbon, net loss of the carbon is become minus. This means in the dry digestion system, carbon is retained in the system. And also nitrogen loss is also lower than the conventional system. Therefore, loss is also lower in the digestion system. So in conclusion, so we proposed a pig farming system using dry anaerobic digestion and rice cultivation system, and we obtained this result. And finally, we find that carbon and nitrogen flows in the pig farming would be improved by using dry anaerobic digestion and rice cultivation system. Thank you for your attention.